Hello dear students, welcome to YourPedia. Today I am going to solve one good question from our NPTEL assignment booklet, which is prepared by YourPedia from the subject power systems. The question number is 9 and the page number is 354. Yes, from page number 354, question number 9 from power systems, that is the concept from Ferranti effect. So that question includes the concept of Ferranti effect and transmission line parameters, ABCD parameters. It's a good question. So number of times this type of question was appeared in GATE and other examinations like ESC prelims and some other examinations. Okay, yeah, a good concept. We can understand the concept of Ferranti effect in this question and some concept about the ABCD parameters of a transmission line. Let's start the question. Read the question carefully. What he is saying: a 220 kV 20 kilometer long 3-phase transmission line has the following ABCD parameters. He is saying that there is a 220 kV 20 kilometer long 3-phase transmission line, 3-phase transmission line. Yes. Now one must understand what is that 220 kV. Is that is sending end voltage or receiving end voltage? By default, the given voltage in the data, if not mentioned, will be taken as receiving end voltage. If it is sending end voltage, examiner or the interviewer will clearly mention it as receiving end sending end voltage. Unless it is specified as sending end voltage, always the given voltage is taken as receiving end voltage. That is one thing. Okay, and that is a line voltage or phase voltage. It is always line voltage. If it is phase voltage, he will clearly mention as phase voltage. A 220 kV 220 kilometer long 3-phase transmission line, phase voltage will be 220 kV. If he mentions, okay, if not, it is taken as line voltage. Yes, what he is saying, ABCD parameters are there. A is equal to D. Yeah, we know that for a transmission line, for a practical transmission line, yes, it is symmetrical. That's why A must be equal to D. If A is not equal to D, first of all, that particular transmission line is not a practical transmission line. Okay, A equal to D, that is given as 0.934 plus J 0.0198. Okay, and no units. A is the ratio of the same constant, same values, same variable. Vs is equal to AVR plus BIR. A is the ratio of Vs to VR. Both are voltages, therefore it is not going to have any units. B is the impedance. The units are of impedance. Yes, what is B? 39.89 plus J125 ohms per phase. Okay, and one more thing I have to mention here, that parameters are always per phase parameters. If you take A, B, C, D, all these parameters, or if you take inductance, resistance and capacitance, are always per phase values only. See, voltage and current and power, these only having some different values for phase and line, for single phase and 3-phase. But whereas when it comes to parameters are always per phase quantities. Need not to mention, always those are per phase quantities, and there is no line to line inductance. Okay, if there are two lines, between those two lines, if inductance is there, that is called as mutual inductance. There is no term like line to line inductance. And capacitance also, between two lines a capacitance will form, that is the capacitance formed between two lines. Voltage, you should not say that it is line to line capacitance. Yes, it is line to line capacitance, but the relationship of line to line capacitance for line to neutral capacitance is not going to be same as that of voltage for a star connection. Like line to line voltage is root 3 times of phase voltage. That type of things will not exist for I can say parameters, RLC parameters. Okay, so V line to line is equal to root 3 times of V phase, and I line is equal to I phase for star connection. Okay, for delta connection, V line to line is equal to V phase, I line is equal to root 3 times I phase. So those are only for variables, that is voltage, current and power. Power 3 phase is equal to 3 times of single phase power. So all these are only for variables but not for parameters. Okay, yeah, he mentioned C. How much is the C value? J 0.002 mho per phase. Okay, the line is energized with a balanced 3-phase 220 kV line to line voltage at the sending end. Now, yes, this given voltage, yes, 220 kV is a sending end voltage. Yes, let me write here it as, yes, what he given, yes, sending end voltage, he given as Vs is equal to 220 kV, and that is line to line. Okay, when the receiving end load is negligible, he is saying that receiving end load is negligible. Immediately we have to understand one thing, that current at the receiving end side, yes, Load is negligible means no load condition. If no load, current at the receiving end side is equal to 0 amperes. Yes, under no load condition, receiving end current is equal to 0. Yes. Yeah. Then find out the approximate percentage change in the receiving end voltage from its nominal value due to Ferranti effect. Yes. Now understand this statement very carefully. He's asking, yes, what is asking? Find the approximate percentage change in receiving end voltage. He's saying that receiving end voltage is changing. Why it is changing? He's changing that because of or due to Ferranti effect. Now understand what is Ferranti effect. Ferranti effect is this. The receiving end voltage under no load or light load conditions is going to be more than the sending end voltage. It's called as Ferranti effect. Why Ferranti effect takes place? Under no load or light load, see, practically all our loads, mostly 99% of the loads are lagging loads. Therefore, most of the times during loaded conditions, voltage will be less than the sending end voltage or less than the rated value. Voltage drop will take place. There is no question of voltage rise during lagging load practical conditions. But fine, yeah, if the load got removed, then what happens? The only current that is flowing in the transmission line is charging current that is absorbed by the shunt capacitances of the transmission line. We are not connecting any shunt capacitance to the transmission line. Those capacitances are formed capacitances. Suppose if you take two phases of a transmission line, phase A and phase B, between these two there is voltage difference. Yes, these two are metallic bodies. Yes, there is a dielectric air, then capacitance will be formed. Those capacitances formed throughout the transmission line distance, and those capacitances are practically distributed, not lumped. But for our easy understanding purpose, we are taking those as lumped. So under no load condition, the current that is flowing in the transmission line is charging current. Because of that charging current, charging current is flowing means which type of reactive power that is flowing in the transmission line, that is leading reactive power. The transmission line is absorbing leading reactive power. Transmission line is absorbing leading reactive power means what? It is supplying lagging reactive power. If this is the case, yes, we know that voltage is going to increase. Voltage rise will take place. So due to no load or light load, the receiving end voltage is going to be more than the sending end voltage, and this effect is called as Ferranti effect. Yes. So because of Ferranti effect, receiving end voltage is going to change. Okay. What is the actual receiving end voltage? What is the actual receiving end voltage? VR is equal to full load receiving end voltage is 220 kV. Yes, it is line to line. Sir, how do you know that full load receiving end voltage is 220? Clearly mentioned a 220 kV transmission line. That 220 is receiving end voltage line to line and under full load voltage. Again, a student can raise a doubt. Sir, the given 220 volts is at the receiving end voltage. Yes, understood. But that is full load voltage or half load voltage or 1/4 of full load voltage or no load voltage. That is full load voltage. Okay. So VR that is. See, we know this relationship. Yes. What is that? Sending end voltage Vs is equal to A times of VR plus B times of IR. We know this. But we are doing analysis under no load. Then what should be replaced with 0? Receiving end current should be replaced with 0. I'll show you the diagram also. Yes, this is the generator. This is the transmission line and no load here. Yes, actually load should be represented like this. If it is a lagging load, yes, lagging static load will be represented like that. Yes. And we are keeping open circuited, so I can put like this and IR is equal to 0. I can put like this, IR is equal to 0. Okay. Yes. So if IR is equal to 0, what will happen to the equation? If IR is equal to 0, so Vs is equal to A. Now this voltage is no more VR, this is VR naught. What is that VR naught? No load receiving end voltage. Vs is sending end voltage. I'll write the description also. Vs is sending end voltage. Vs is sending end voltage and VR naught is, yes, no load receiving end voltage. Receiving end voltage. Yeah. Now, what is VR naught from that? What is VR naught? VR naught is equal to Vs by A. VR naught is equal to Vs by A. Now what is asking? He wants the percentage change in the receiving end voltage. Nothing but regulation. Voltage regulation. What is the formula for voltage regulation? Percentage voltage regulation is equal to, see, one must understand the regulation carefully, the formula. Percentage voltage regulation is equal to mod VR naught. We have to take the no load receiving end voltage only magnitude minus mod VR. See, this is a change. See, the voltage is changing from VR to VR naught. This is full load voltage, full load receiving end voltage. Okay, the change from no load to full load is receiving end voltage is mod VR naught minus mod VR. But I want as a percentage of full load voltage. Yes, how much percentage of full load voltage it is rising. Okay, so that's why we are taking mod VR here. See, in some interviews they will ask you to explain this voltage regulation formula, and they will ask many crash questions. Questions will be like this. Yeah, you are taking magnitude of voltage or total voltage, only magnitude. While you are finding voltage regulation, you have to take, while finding voltage regulation, we have to take always a load constant, means a full load. This is for full load only we have to calculate, and for the same power factor. See, if the power factor is leading during full load, this magnitude of voltage may rise. Yes, so there are many things to keep in mind while calculating voltage regulation. Into 100. See, understand why we are doing by mod VR. This is a general regulation. For a transformer, we have one more regulation called regulation. See, total regulations we have regulation up and regulation down. For a transformer, we are taking no load voltage here for a transformer, but for transmission line, except for transformer, for all electrical machines, we are taking full load voltage here. This will be regulation up. Okay, why? Because see, this value is less. No load, full load voltage is less when compared to load voltage. In the denominator it is more, then the value is going to be less. It is called as down, regulation down. For transformer we are calculating regulation down. For remaining all other electrical equipments we are finding regulation up. This is less value when compared to this value. See, for a transformer, let me write a note point here. For a transformer, yes, regulation, let me write clearly. Yes, percentage regulation is equal to, in fact, percentage voltage regulation only, percentage voltage regulation. Yes, percentage voltage regulation is equal to mod VR naught minus mod VR by mod VR naught only, it's not mod VR, into 100. So as this is a more value, no load voltage is always more value, therefore it is going to be less value you are going to get. That's why it is called as regulation down. Remaining all are regulation up. Therefore by default regulation means regulation up only. Sir, why we have to take no load here, why we are taking full load here? On the nameplate details of transformer, the mentioned voltage is no load voltage always. But remaining on all electrical machines, then the mentioned voltage is a full load voltage. That's why, see, what the data we have, that only we will be taking as reference. Now come here. What is mod VR naught? Mod VR naught is equal to mod Vs by A. Mod Vs by A minus mod VR by mod VR. So what is this mod Vs by A? 220 by, yes, A. In fact, that is magnitude of A. Let me take like this. Yes, magnitude of A minus, this is 220 by 220 into 100. Now here we have to find the value of A. So A, he mentioned already, A is equal to, he given it as a 0.934 plus, let's go back and recollect the value of A from the given question. 0.934 plus J 0.00 plus J 0.0198. Yes, plus J 0.0198. I want its magnitude. Magnitude of A is equal to under root of 0.934 square plus 0.198 square. See, you are going to get this one as approximately 0.934 93420. Almost it is same as of this part. Why? Because this part itself is 0.01. See, no need of calculator in fact for calculating magnitude of A. This is, if you square this one, that is going to be decreased further it will be decreased. Therefore we are going to get 0.9420 magnitude of A. Now yeah, here one question can be raised from students, that is, so while finding voltage regulation, we have to take a phase voltage or line voltages? Yes, percentage voltage regulation is equal to mod Vs 220, this is the line voltage, by magnitude of A 0.934 minus of 220 by 220 into 100. If you observe it, we take a line voltage. Even if you take phase voltage also, 220 by root 3, 220 by root 3, 220 by root 3. So root 3 will get cancelled. Actually we have to take per phase voltage only, but I am taking either line voltage or per phase voltage, both are same answer I am going to get mutually, that by root 3 is going to cancel. Now let's calculate this value. Use your scientific calculator. Yes, use your scientific calculator to calculate this one. Okay, 220 by 0.934 minus 220, yes, divided by 220 into 100. Yes, this is 7.066. This is 7.066 percentage. Let's see which option is going to match. Let's see which option is going to match. See, look at option A. It is 8 to 8.1% increase. B is 6 to 6.1 increase. C is 7 to 7.1% increase. Option C serves our purpose. Correct answer. And D you see 6 to 6.10 decrease due to ferrite effect. Receiving end voltage will increase, it won't decrease. Yes, option C is the correct option. See, the question is simple if and only if you know the concept. See, there are many possibilities to commit a mistake here. In GATE examination, mainly students will confuse between which regulation we have to calculate. They will get confused between transformer voltage regulation and transmission line voltage regulation. This is one of the very important point. This way questions will be simple, but a small trick will be there in the question. Yeah, this way we are going to solve many of NPTEL assignment questions on power systems. Thank you.